All right, dude, we are live. What's up, guys? This is Dem Keys, and holy shit, dude. It is 2026. This is the very first stream of 2026. Happy New Year. I was actually hoping. So it is currently the 3rd of January, and I was hoping to do a stream yesterday, but then uh, just didn't happen. Um, yeah, dude. It's 2026. That's crazy, man. Give me a second here. I need to. Which one am I looking for? So what I could do is because I want to open up the what do you call it? What is this being used for? Is this being used for like ESP32 stuff? Okay, let's not save this. Um, Temporarily, what we could do is just so we're able to use this exact thing, this exact TMUX session, because I want to open up HMM, Hacker Mind Map, just so we can do some stuff. So, I'm gonna do HMM. Oh, wait, back up. Hold on. We're gonna get to talking about this year, dude. I don't want to talk about last year. Holy shit. I'm so glad that 2025 is just over and done with. I'm not even exaggerating when I say fucking 2025 was a shit year. It started out shitty and just got shittier and shittier up until mid 2025. And then things kind of got a little bit better. Oh shit, this thing is stuck. You know what? I need to look into why exactly this specific thing happens, the thing that's happening right now. I'm going to get to this later on. For now, I think this entire shell is stuck, and this specific thing seems to happen only with HMM. I need to look into this. I need to look into why exactly this happens. For now, though, how do I create a new window? C. Yeah, okay. So we're going to cd into documents, and here we're going to create, um, yeah, here we're going to create a new mind map called, yeah, let's just say New Year, or let's say, yeah, whatever, New Year 2026. Okay, that is saved. Actually, is it saved? I'm not sure if it's saved. Okay, so right, we are in 2025. I don't know if I completed what I was saying about. No, did I say we are in 2025? We are in 2026. 2025 is over. I don't remember if I finished what I was saying. Like the year started out shitty, and it remained that way until like mid 2025, and then it got slightly better, but like uh, wasn't all that great. Let's just say Q3 also was there was stressful times a lot. Q4 got a bit better, definitely, definitely a lot better than the rest of the year, and yeah, I'm glad that 2025 is over, and I'm hoping that 2026 is a much better year. Now, I don't usually do things like, resolutions, and I can't remember if I've ever done this thing where, I mean, I might have done it at some point in time, but I can't remember if last year and the year before I did this thing of like what do I want to do this year? Because I've always been the kind of person that I don't usually do those things. New Year's resolutions, I learned a long time ago that, at least for me, I'm not gonna generalize for everyone, but at least for me, they don't really work out. Because if I really want to do something, I'm gonna do it. Me, saying that I've created a resolution to do so and so thing, it's not gonna motivate me to do it. If I have the motivation to do the thing, like if I have the willingness to do it, I'm not even going to need to, put it into a resolutions list. That being said, like I said, this applies to me only. I'm not like generalizing for, I'm not hold on. Why is the thing not being shown here? Which specific one are you guys looking at? So there's other laptop, which is this, I guess. You guys are not seeing any of. Oh, okay. Okay. Here's what I need to do then. I need to save this and close it and come here, cd into documents, and then open up. Actually, no, hold. What is the name? New Year, I think. Man, hold on. Actually, probably shouldn't be doing that. I mean, no, yeah, that should be fine. What is it? New Year 2026. And I should probably rename it to .hmm just so I know that it's a mind map. Okay. Right. HMM New Year 2026 .hmm. Okay. Now you guys can see it. So, like I've said, I'm not really the kind of person to make New Year's resolutions, and I'm not going to be doing that. What I do want to do is make a list of what I'm hoping to accomplish this year. I'm not going to stick to the list very strictly. Like, the things that I'm listing, they absolutely must happen, because things change, right? Or throughout the year, something might change in the field in which I'm hoping to accomplish something, because of which the goalpost, so to speak, might get moved, and then I might want to accomplish something even more than that, or I might want to accomplish something completely different within that same field, but something completely different. So, like, I'm not gonna strictly stick to the list, but I do want to make a list of stuff that, you know, that I'm kind of hoping to do this year. So, first thing in the list, um, I'm definitely I want to do like a massive deep dive into, deep learning and robotics. This is a new one for me actually, because last year I'd said the exact same thing. I wanted to go deeper into deep learning. I did not include robotics. At least I don't remember including robotics. I also wasn't nearly as interested in robotics at the time. Now, because I have, a lot more equipment, I have, I'm a little more familiarized with ESP32 and embedded embedded Rust programming for ESP32, because I've been introduced to all of these things, and throughout this year I've been learning about all these things a lot more. So now I'm actually a lot more interested in this. And there's also the fact that robotics has just exploded in the past year, and in the coming year it's gonna go crazy. Like, I haven't even done my research on this, like on the current news on robotics, but I can tell you without a doubt, AI in general is gonna explode. To be clear, I'm not talking about like AI businesses. I'm talking about AI tech. The business side of things, I'm not really involved or even interested in any of that. A lot of times you'll hear people saying, "Oh, the AI bubble is going to burst." They're talking about that shit. They're talking about like people throwing money into AI. I'm talking about AI actually being developed, like the tech that these businesses use. I'm talking about that tech being developed, the various ways that that tech gets developed, and that's where deep learning comes in. So I'm very much interested in like the engineering side of the engineering side of things in both of those fields being deep learning and robotics. I'm very much interested in the software and hardware engineering in both of these fields. So okay, I guess that's that's where we can start, right? So we can say deep learning, um, software. I mean, I know it's software and hardware, but like I should be more specific, right? Um, what would I what how would I categorize the models that would be running um, on like microcontrollers and stuff? I guess those are called like edge devices. Generally, when people say edge devices, they're talking about something like um, a phone or a Raspberry Pi or something. I don't know if they classify microcontrollers as edge devices, though the idea behind edge devices, the idea behind running AI models on edge devices is that um, you're basically making these models capable of running on devices that are much more resource constrained than a computer or a laptop. Because something like, let's say, a desktop these days, right? What's more common in terms of memory is um, at least 8 to 16 GB. 8 would still be considered low end. Like that's how high memory requirements have gotten these days. 8 would be considered low end. If you have 16, that's considered like mid range, or you're getting to mid range. And these requirements, they're not going to reduce. They're going to increase. You know what is interesting? What I'm really interested in exploring. There's this thing. This is like a small side tangent. There's this thing that I've been noticing in the past month. I think there's been a lot of news of RAM becoming a lot more expensive, and I think GPUs are also starting to get more expensive, or maybe they're running out of stock again. I don't remember which one of those two it was, but the point is, these this hardware that is very heavily used in computers for various things, not just gaming, for various things. This hardware is about to become a lot more expensive, right? So a lot more people are slowly starting to rely more and more on um, on smaller devices. I'm not sure what to call what category to put them into, but a lot more people are starting to rely on stuff like Raspberry Pis, for example, or some sort of um, dedicated accelerator, something that can, for example, do, I don't know, GPU calculations, and it has, you know, cooling systems and stuff set up, and this thing is meant specifically for doing calculations. It's essentially a compute node, right? Um, I'm seeing people moving their focus more towards those kinds of things. Something that I'm really hoping happens is that the Raspberry Pi becomes cheaper this year. If that happens, actually, you know what? I'm hoping a new Raspberry Pi comes out, because when a new one comes out, then the old one is going to become cheaper. And then I'll buy the old one because I don't have the money to buy a new one. It's not like the new one is like super expensive. It's just that it's expensive enough that it's a little too much for me. In general, those things are affordable. It's not like they're super, highly priced, but it's a bit too high of a price for me. And another thing is I kind of want to order it directly from the suppliers, directly from the manufacturers. I don't want to go and buy it from one of the shops in my region, because there tends to be a bit of a markup when you try to buy it from the shops here. They will buy it in wholesale so they can get it cheaper. But then because they're buying it to sell it, there's also some sort of tax that they have to pay. I believe that's the concept of import duty. So they have to pay a certain amount of money to the government because they are importing this stuff to in order to sell it. So there's that there's the shipping cost, there's the import cost, and then they have to put their own markup so they can make a profit, right? After you've added all of this stuff onto the base cost of the Raspberry Pi, it becomes very expensive. So buying it locally is not really, I don't want to do that. And I could try buying it off of AliExpress, but like at that point, if I'm going to be doing that, then I might as well go for one of the knockoffs, or one of the, I'm not sure what other word to use, one of the off-brand ones. Let's call it that. I'm better off going for one of the off-brand ones. There's stuff like Orange, there's Banana, there's two or three more. The problem there is, a lot of times when you look at software that's aimed at specific hardware, at specific like architectures and stuff, it can make a difference whether it's like a Raspberry Pi or an Orange whatever or a Banana whatever. I need to do more research on these, because it should be as simple as, it should be more about the CPU architecture, because the programs and the entire OS and all of that is being executed by the CPU. So that specific CPU's architecture is what should matter. But I need to see if anything more than that does matter, because there have been situations that I've read other people's stories where it did make a difference, and the software, it's not always a guarantee that it's going to work. It could also just be that I happened to see a few bad reviews initially, and that kind of painted a bad picture for me of a bad image of the off-brand ones. But I do want to try out the off-brand ones if they are cheaper. That is. That being said, yes, Raspberry Pi. I wanna buy a Raspberry Pi for myself. I do have a Raspberry Pi, an older one, a Model 3B Plus. Something that I want to do is I want to get a Raspberry Pi that has PXE boot already enabled, because I'm going to be honest, I do not want to do this. What do you call it? I do not want to do this SD card thing that you have to do with Raspberry Pis. That's like my only issue. It's because it's because I don't have a good quality SD card reader. I could just buy a good quality SD card reader. To be honest, I could just do that, and then I could easily flash the thing on there. Another reason is that I actually don't even want to connect a display. I want to use a Raspberry Pi as just a compute node, or just as a headless server, something that's running, but like you don't have a display attached to it. It's running, but you can SSH into it and you can do stuff on it. You don't have a display connected to it, and that's actually really useful, because the way that I'm doing this, in case you guys don't know, because I haven't really spoken about my setup all that much, ever since, like, I first introduced what I was doing here. Basically, what you guys are looking at, if you look at the bottom left and bottom right, the the window in the bottom left of the screen and the window in the bottom or center right of the screen. That is, hold on, this window where you're seeing stuff changing right now, and this window where you're seeing stuff changing right now. So this is the bottom left, and then this is the bottom right. Now, both of these are actually tmux sessions, and in each of these tmux sessions there are multiple shells running. Each shell gives me a different terminal instance, so I can launch multiple programs in that way, and that's exactly what I've done, right? Each of these are separate tmux sessions, but both of the tmux sessions are running on one PC. And I can SSH into that PC and attach to the tmux session and control the tmux session from another PC. So this way I can have like a multi computer setup. It'll essentially give me a multi monitor setup without actually needing to do a multi monitor setup. So similar to this, I could have some software running on a Raspberry Pi, and as long as the Raspberry Pi is connected to my network, I can easily SSH into it and run whatever calculations I need to run, or if there's like a build process that needs to be done, or whatever. I can use it as like there's a lot of different possibilities. I can set up a sort of I can set up a home lab with various types of tools installed for various purposes. I can set up different types of servers on there. There's a bunch of different types of testing that I can do. There's so much stuff that I can do. It is insane being able to run these devices in headless mode. It's insanely powerful. And this isn't even some new tech that I'm talking about. This is like a lot of people have been doing this already. Something that I would be interested in is if I were able to, because dude, okay, here's what I'm trying to do. Okay, I need to be able to power the Raspberry Pi. I can power it directly from a power supply if need be. One challenge is that the specific Raspberry Pi that I have, you definitely need to log into it at least once with a display attached, so that you can go in, enter a specific command to enable PXE boot. And that is with the older Raspberry Pis. Like the one that I have, it doesn't have PXE boot enabled by default. So you have to actually go in there, boot it up at least once. That means you have to hook up a display to it and boot it up and uh, enable the PXE boot. And after that, you can disconnect it from the display and run it in like headless mode. So I wanna buy a Raspberry Pi that already has PXE boot enabled, because I don't want to connect the Raspberry Pi to another display. I'm mainly interested in using its computational power, so I can like hook it up to my network and just SSH into it. Besides, the majority of my workflow is primarily terminal based anyways. I'm doing a lot of stuff in the terminal anyways, so you know, having a Raspberry Pi that I can SSH into and run calculations and stuff, it just makes sense, right? Okay, hold on. How do I even like? There's so much stuff that okay, here I can do. I can say home lab using RPi. Uh, RPi with PXE boot. Deep learning. Deep learning. I'm gonna say desktop. I can change this. like later on, and embedded. See, because previously I was saying that I wanted to explore like the hardware and software side of it, and I was going to write hardware and software here, but then like I wasn't sure exactly how I would go about splitting it up into, further branching it out. I wasn't sure how I would go about doing that. Deep learning on desktop and embedded. Then I want to go into robotics, definitely. Robotics is going to be mainly embedded. Um, this is going to be ESP32 with Rust. Um, there's going to be more stuff that I want to add to this. I need to get back to data science. I definitely need to get back to data science because I never moved forward with that, with those Kaggle courses, because I kind of got distracted with other stuff. I want to move forward with that. I want to do more data science stuff. I don't know if that's the odd thing. As much as I try to keep coming back to data science, I'm always getting distracted with other stuff because I'm really interested in data science because it teaches you a lot of different ways to deal with data, not just handle and manipulate data, but to actually like find patterns in data and try to find answers mathematically by looking at the data, by running algorithms on the data. There's a lot of powerful stuff that you can do through data science. So I am very, very much interested uh, in data science. Let's just do Kaggle Learn here. Then game dev, Rust, Rust with Nano. I wanna work on at least one game, but like I don't want to make it like a big project. I want to make it a small project. Just like I don't even know if I want to call it like a serious project. I just want to build a game in Rust using Nano and the various crates and stuff. I feel like that'll be great practice for me. Actually, this reminds me of I needed to write down project ideas. Um, yeah, there was something I wanted to do with waves. And there was a conversation I was having somewhere with Gemini that I cannot remember where it was. I'm gonna have to find it. I don't remember if it was in Gemini CLI or if it was um, in the web version. I'm gonna have to search through all the conversations that I have there. If it's in CLI, then I should be able to resume it very easily. Actually, okay, hold on, wait. Um, Rust Wave game. Let's just do that. Okay, because once I started looking into the concept of waves, I'm dealing with waves in two very specific fields. One is audio, and the other is radio frequency. I'm dealing with waves in both of these fields. Both the fields use the concept of waves to represent the signal, right? But the waves are doing different things, and I want to understand the concept of waves in general first, because I feel like that's like some base knowledge that I need to have. I do already kind of understand the concept of waves, like it's essentially a signal propagating through time, and you are able to represent it in various forms. One of the most common forms, and a very natural, well, I don't know if I should call it natural, but a very common form, a very common base form that's chosen, or shape that's chosen, is a sine wave. A sine wave basically represents an oscillation over a certain period of time, and you can have you can set a frequency for this sine wave, which basically defines how many times the wave completes one whole oscillation within 1 second. One whole oscillation is basically the wave going from 0 up to 1, then coming down to 0, then going down to -1, and then coming back up to 0. So that's one whole oscillation. And this is the entire concept, right? This is the concept of a wave. This one simple thing, it is able to represent, like, you are able to build a lot of, actually they have, you're not just able to, they've built a lot of very powerful concepts on top of this. Like, for example, the what was the thing called? I forgot the term for that, but there was a thing that represents the rotation, and this is the rotation that's being presented in that wave. um, I forgot exactly what it was, but the idea was that it shows you where on the wave you are, or in this specific point in time, what your current rotation is. And you can like plot this rotation on, like, using a unit circle. I need to try doing that at some point later on. But yeah, there's a thing where you can find what your rotation is on like a unit circle at a specific point in time in that wave. Another concept is the concept of amplitude, which is basically just the strength of the signal, how high the thing is. Like, let's say between -1 and +1, if this reminds me, this with amplitudes, you also have the concept of peak and trough. A peak is basically as high as the thing can go. In this case, it's 1 on the positive side, and a trough is as quote unquote high it can go in the negative direction. And in this case, it's -1. There's a lot of this is what I was talking about. There's like a lot of very interesting concepts that are built around this concept of a wave, and then it goes further into creating complex sort of waves. Like, you have, okay, so you have three basic waves, which are your sine wave, square wave, and sawtooth wave. And each of these waves have very specific properties, because the wave, it behaves very differently, right? And depending on what you are trying to use this wave for, you're going to get different kind of behavior in that as well. So in the case of audio, you can hear a very clear difference between a sine wave, a square wave, and a sawtooth wave of the exact same frequency and the exact same like amplitude. Um, Anyways, okay. Enough about waves. I need to understand waves, and in order to better understand waves, I was like, okay, let's try to make a game around the concept of waves. I'm still not sure how I want to go about the entire thing, but yeah, I do wanna set up something like that. Um, what more? What more? I did also wanna. Oh yes, dude. Okay, I think it's time that I start putting in more effort into trying to grow my online presence. So we can say streaming. Okay, I want to add VTubing to the list, but then I'm not even sure like what exactly is that supposed to mean here, because like I'm already VTubing. Oh yeah, VTubing app, VTubing app, with uh, Rust and Nano, with Rust, Nano, etc. Yeah, I need to work on this. I need to create that um, auto clipper script. I need to work on that script, because I want to build something that I can hold on. Yeah, okay. I wanna build a sort of tool that I can feed one of my VODs into, and it's gonna analyze the entire VOD in various ways, both audio and video, and then it's gonna pick what it considers to be the most interesting parts. I'll give it like specific subjects for what it should be looking for, because my streams, they are less entertaining and more informative, more like, I guess you can call it educational if anyone is learning anything from this. But like they're more on the informative side, and they're more like on the chill side. I don't do like high energy, very entertaining, funny content. Maybe every now and then there'll be the rare funny kind of bits here and there, but for the most part, it's like a whole lot of me chatting and a whole lot of like informative stuff going on, a whole lot of educational stuff going on, because I'm usually learning. I'm usually doing co-working and studying streams. So keeping those topics in mind, I would want the auto clipper to find clips that it finds within those categories. Like it can look at specific segments and analyze that and determine if something has interesting information in it, or if there's something educational, or if I'm talking about something that happened in the past that made me discover something, or some kind of experiment that I've done, or something new that I want to introduce, or whatever. Right? There's so many different things that I can clip even within my own category, even though my content isn't like high energy, like very very funny comedy kind of content. Even though my content is not that, uh, even within my own content genre, I guess you can say, I can still find stuff that I would be able to clip and then upload. Now, here's the thing, right? This is an unfortunate reality. It's incredibly sad to like see this happen, but over the past year, I have discovered this not by myself, through other people. I've watched this happen. Initially, I was like, oh, people might just be thinking that this is the case, but that's not really the case. But no, that is really the case. People weren't just thinking. People tried this out, and that's how they discovered that, oh yeah, this is a thing. The thing that I'm talking about is these social media platforms, dude. TikTok, Instagram, X, or Twitter, and to a certain extent also YouTube, if you are like regularly uploading there. A bunch of these platforms, they very much expect you to upload, not daily, multiple times a day. I am not exaggerating about that. Like, dude, I am not exaggerating about that. These platforms, they want you to be on the platform. They want you to keep people on the platform. So they want you to upload more and more and more. Like, dude, imagine having to edit content, multiple videos that you have to upload in a single day. That's a recipe for burnout. You have to find a quicker way to do this kind of to produce this kind of content, right? So that's where my idea for the auto clipper comes in, because the platforms are expecting so much content. They're expecting multiple uploads daily. So the for for lack of a better term, the quality of, or basically, because I can't put this in a different way, the quality of the videos that are being uploaded, it kind of goes down. The production quality goes down, because there's only so much that you can expect somebody to do in terms of production quality when you are expecting them to upload multiple times a day. And especially if it's like, one or two people who are uploading the content, or quite often it's one person, right? Unless they have an entire production team behind them, it's usually one person. Or every now and then there might be like, duos of people, or maybe a small group of people that are making content for a certain for a certain entity that represents their group. Where was I going with this? I forgot where I was going with this. Yeah. Anyways, this is where my auto clipper comes in because I figured, you know what? Since I, what was I saying? Yeah, since I absolutely do not have the time to go through every single VOD of mine and like clip things, I'm going to be honest, for anyone to do that is a huge waste of time. Like, I'm not talking about people clipping your streams while you are streaming. That's not a waste of time. That's actually a good use of time. That is if you have people watching, and you immediately like, or somebody immediately clips something that they find interesting, and then the clip is there, so you can download it whenever you need, and you can upload it. But like, if you are somebody who's just starting out, or if you are somebody who as it is has a very low viewership, then you're like the only person that's going to be going through the VOD, right? Unless you want to pay someone to do it, you're going to be the one going through the VOD. So imagine having to go through like a 1 or 2 hour VOD after you're done streaming, having to go through the 1 or 2 hour VOD just to find a couple of interesting clips. To be clear, I'm well aware that there are a lot of people who have done this. What I'm saying is, I want to find a more optimized way to do it. I'm very well aware that people have done this, but in my opinion, that ends up being a not so efficient use of your time. If you can find a more automated way of generating clips out of one long VOD, and then you can like sift through those clips and pick the ones that you feel are the most high quality, that would be a much better use of your time. That would honestly be a much better use of your time, because that's, if you think about it, an auto clipper creating a bunch of different clips of your VOD is similar to you having an audience of, let's say, 20 people, and maybe 10 of those people, they are very enthusiastic about clipping stuff, so they start creating a bunch of clips, and you have like multiple clips showing up of each of your streams. It's more or less the same thing, in terms of, having to sift through clips. There's the obvious difference that, in one case it's being done by human beings, and in the other case it's being done by a bunch of AI models like working together, right? There's that obvious difference. But other than that, you are going to be spending similar time trying to sift through clips to find the most interesting one that you can post. So with an auto clipper, even if the auto clipper produces, out of a 2 hour stream, even if the auto clipper produces like, let's say 30 clips. I don't know. That's still a very big amount, but let's say it produces 20 to 30 clips, right? Because you're giving it different parameters for what it should consider interesting, and then there's like different logic, there's different algorithms that you'll be applying to determine that, okay, based on these different modes in which different models found certain segments interesting, which of these segments overlap, and if there is an overlap, then like, can we analyze those specific overlapping segments and find something that's interesting, or clip the entire thing and then just let the user, or the user being whoever is using that auto clipper, we can just let the user sift through all of those clips. There's an algorithm that you're going to have to set up to actually stitch a lot of the different results together. I forgot where I was going with this. Anyways, um, okay, just a second here. Give me a moment. Right. Okay. So, Auto Clipper script. It's initially going to be in Python because I value um, I value the ease of use a lot more than the performance in this case. I'm not very worried about performance. Otherwise, I would have gone for Rust. I would have 100% gone for Rust. But in this case, I value the ease of use a lot more because Python has it has a very concise syntax, and I would be able to accomplish a lot more in terms of creating functionality and prototyping stuff and improving the prototype. I would be able to accomplish a lot more by using Python in this case rather than using Rust. Once I have the entire prototype down, um, once I have the entire program down, once I know exactly what I want, because currently I don't even know exactly what I'm looking to do because there's like multiple parts involved here. First, I have to extract a transcript. I have to generate a transcript based on the audio of the VOD, right? The transcript is going to have timestamps along with the text that's being displayed or that's heard during those timestamps. Then I feed that transcript into another model that analyzes it and then determines that, okay, from this point to this point, there was something interesting that happened. From this point to that point, there was something educational that happened. From this point to some other point, there was a story that was being told. Those kinds of things. So it'll give us like interesting timestamps or timestamps that it finds interesting based on subjects that I've told it to look out for, right? I'm almost certain that I'm going to be using a language model to a certain extent for this because, yeah, I don't know, because bare bones NLP methods have been mentioned, but when I also asked Gemini that, okay, all of these bare bones NLP techniques that you have mentioned, which I would be using individual models for most likely, or I would be implementing them myself using, one of the NLP libraries, which I'm probably not going to do that because like you still need weights a lot of times. If you're using a model, the model has to be trained. It, there's a lot that goes into training. So most likely you're going to be using a model that's pre-trained, and so you're going to be getting the weights of the model, right? Where was I going with this? I forgot where I was going with this. I was talking about NLP. So the I was asking Gemini that, okay, you have mentioned multiple different NLP techniques here. Is it at all possible that with today's LLM technology, with how far language models have come now, and considering the fact that they're called large language models because they're trained on like massive amounts of data, is it possible that all of these individual NLP techniques can all be consolidated into one model? Would I be able to accomplish like that? For what I'm really asking is that would I be able to accomplish all of these different NLP tasks that you have described through one language model, one or two or three large language models instead? And the answer was a resounding yes. You would be able to because large language models they are built to have conversations about things. So as long as you are able to get them to understand the input that you're giving, which is going to be a separate kind of challenge. But I can work around that. I'll have to be a little creative with how I set that whole thing up. But as long as you're able to get them to understand the input and also your instructions, as long as you're able to get them to understand your instructions, you should be able to accomplish a lot of those things. I believe I was in the process of explaining well the process of the auto clipping thing. So that's like one segment of it, one section, right? We analyze the audio, produce the transcript, feed the transcript into something so we can get some timestamps of what seems interesting. Then we haven't touched the video yet, right? So we're probably going to feed feed these frames into some sort of vision language model, and then get some information about that as well. That might give us some interesting timestamps as well. That'll give us like a separate form of timestamps, which is like different from the transcript. And then we can use those timestamps and feed that into another model and ask it, hey, based on what's being described here, what do you think? Actually, it's a vision language model. We don't need a separate thing, right? If it's a vision language model, then we can just feed the frames into it and then ask it a bunch of questions, tell it to tell us what it found interesting based on certain topics that it's looking for, right? So that'll produce a separate set of timestamps. And then we can look at the overlap between the previously produced set of timestamps for clips in this case, not timestamps for the transcript. Because in the previous step, the final output would have been timestamps of like, hey, from this point to this point is one clip. This is interesting. From this point to that point is another clip. That's interesting. These are points. These are different points that you have to check out, right? That's the output that you get. And then in the next step, you get another set of outputs that is based on the vision, what the model is seeing. And then in the third stage, there's I forgot exactly what that stage was doing. Yeah, I forgot what it was doing, but there's a thing that happens there as well. Either that's where the entire thing gets stitched together, or maybe there's further processing that happens. Maybe we take a look at these timestamps and like produce clips and then feed those clips into the model and have it determine like, hey, is this interesting? Is that interesting? And stuff like that. Or if there's nothing more to do, then we can just take a look at the timestamps produced by the first stage and the second stage, which is, you know, the audio analysis stage and then the video analysis stage. And then based on that, we can write some sort of algorithm that looks at the overlaps between both of these sets of timestamps. And wherever there's an overlap, we can try to clip that and just save that as an individual video. And then finally, me, the user, or anyone else who's using this model, they're going to be left with an entire directory of maybe 10, 20, 30 small clips, depending on what length threshold I set, which I think I'm going to be setting a threshold of anywhere between 30 seconds to 3 minutes. I'll have to see, because here's another thing, right? I want these clips to be short enough that people won't get bored watching the thing, but like I also want them to be long enough that some of these platforms won't just bury the video. Because sometimes, like I've noticed this thing as well, some of these platforms, they want it to be small, but they don't want it to be really small. So I have to find like what the sweet spot is there. Anywhere between, like in some cases I've noticed that they want it to be slightly above 1 minute, and in some cases I've noticed that anywhere between 30 seconds and 1 minute seems to be fine. And of course in some cases they also prefer anywhere between 1 to 3 minutes. Either way, I want to set up a thing. I'm not like strictly, I'm not like very much worried about that happening, like the video getting buried and stuff, because that's the whole idea behind being able to post multiple times a day and being able to post like multiple such videos, is that I don't have to worry about these, you know, little micro details. So I can set a threshold for anywhere between 30 seconds and 3 minutes, and there can be a clip produced that could be, you know, it could be 1 minute and 10 seconds, it could be 2 minutes and 30 seconds, it could be a 50-second clip, 45-second clip, whatever, right? it I'll get a bunch of different clips. So I'm gonna end up with a directory of anywhere between 10 to 30 clips, and that's where the human comes in, because that's where I'll be looking through each of these videos, and I'll decide which one I find interesting to upload. So that's my auto clipper, and I forgot I forgot where I was going with this. Yeah, that's the Auto Clipper script, and I definitely want to get started with this because this is going to help my streaming. Like that's one of the reasons why it's being why I'm building this in the first place, right? Because um, I want to be able to produce these. Oh, yeah, I want to be able to produce these clips. Just a second, I need to. So I need to be able to produce these clips and be able to post multiple clips a day. I can also mix things up. Also, I'm probably gonna get not probably I'm going to get Twitter Blue because as unfortunate as it is, like as sad as this sounds, um, Twitter, like if you're looking to get your content out there, then Twitter definitely helps with that. Um, Other platforms like TikTok and Instagram, you should absolutely be targeting those platforms as well, posting on those platforms as well. But Twitter also, it definitely helps build an audience and get eyes on your stream. But something else that's unfortunate about Twitter is that ever since they got their blue check subscription thing, ever since then they have slowly been kind of pushing down all the unverified, as they call them, unverified accounts. Basically, meaning if you are not a Twitter, what do they call it? Premium. If you're not a Twitter premium or X premium subscriber, then the chances of your comment being seen are pretty low. Like your comment is going to get buried below a bunch of other um, actual verified accounts, and you're not even a bot. You're a you're a legit human being. Your account is just a regular account that you have been using for years before Twitter was bought out and turned into what it is today. You have had your account for a long time, but that's not going to mean jack shit. Your posts are just gonna they're gonna get buried. Your posts aren't even going to be pushed out to other people. Paying them gives you a slightly better chance of having their algorithm push your content out to other people. And the good news is they have now created like multiple packages, and one of them is a very, very basic package, which is like $2 a month. And I'm gonna go I'm gonna go for that. I'm gonna try that. I'm gonna take a year's subscription because it's only gonna be around like well, $2 a month, but like if you go for the yearly subscription, it's a dollar something. So that in total, that comes to around, I think it was somewhere close to $20. And yeah, that seems worth it. It seems like a nice small investment if I'm able to use it to get my content out there. And here, I guess I am able to kind of justify it because one of the reasons why I never bothered with the blue check thing, aside from the very very negative connotation it had earlier, the very negative is connotation the right word here? The very negative energy that it was getting initially from a lot of like, dude, there were a lot of clowns that were straight up blocking others for being verified on Twitter. Like that's crazy, dude. Anyways, um, what was I saying? Shit, forgot what I was saying. I was talking about something to do with the negative energy that the blue check thing was getting. I forgot what I was saying, dude. Oh, well, okay. I was talking about like, okay, in the past, I told myself that I am gonna I'm gonna pay for this once I'm able to justify the cost. And the only way it's going to be justified is if I'm actively using it to promote my platform and to grow my platform. And if that actually, translates into some form of income, which can then be used to pay the subscription. Um, what was I saying? Yeah, yeah. So now, and previously, it was they didn't have like this very super basic package. Now they have this incredibly basic package, which is like $2 a month, right? Previously, they didn't have that. So now it's actually cheap enough that I don't need to have this justification, because I'm only paying like around $20 a year for this thing. And within this year, I'm going to get as much usage out of it as I can, because I'm going to be spam posting a bunch of the clips of my whatever stuff I'm doing. I also want to post more regularly about what I'm up to, um, in terms of my deep learning research, my robotics research, just in general home lab research, ESP32 research, Rust research, bunch of different things, right? I wanna post a lot more. So I feel like I'm definitely going to be using not just Twitter, but like TikTok and Insta and all a lot more. And one added bonus, because like I don't post often on Instagram, unless I have some sort of image or video to post, because that's, primarily image and video. Um, on TikTok, at one point they introduced the concept of text, so you you don't have to even click a blank image. You don't have to take like a blank image and overlay text on it. You can quite literally make a text post where they'll give you controls to, you know, create a text post. So people have been using that a lot as well. I don't know if Instagram has done that, but yeah, I'm a lot more active on platforms like Twitter. No, not Twitter. TikTok and Threads, and then every now and then there's on Instagram. I just don't touch Twitter all that much anymore. In the past year, I rarely touched it, and recently I checked it out again, and now I'm planning on becoming a lot more active with it. I guess I can add social media to this. Social media posting. Maybe I should also add regular. Now, here's the thing. I have an idea for an auto clipper, right? I don't I don't really have anything set up yet. At some point I should get to that. I should set something up so I can prototype and like see how the entire thing goes. I can take like a small clip. Oh, another great thing is that you have libraries like FFmpeg, which make it easy to just cut videos and split audio and video. It's a comprehensive set of tools. It's a very, very sophisticated tool that you can use in various different ways by giving different, arguments and all when calling the program. But the great thing is that people have written libraries that would call into this program to do exactly that. So you are then able to programmatically um, do stuff. And quite often through those libraries, it tends to be a little easier than actually using the CLI, because with the CLI, you would need to know exactly what you're looking to do. Because there's a like I said, it's a very comprehensive toolkit. It's a very sophisticated toolkit. There's a lot of flags. There's a lot of different things that you can do. Sometimes different combinations of flags, they produce different types of behavior, right? It's a very sophisticated tool. It's amazing, right? But you need some form of automation to help you do stuff with this tool, unless you want to spend hours or days studying the entire tool. You would need some sort of automation to handle a lot of the complexities. In my case, I would usually just ask Gemini. I would say that, hey, I want to use FFmpeg to do so and so thing. Like, I don't know, split the audio and only take this specific chunk from this timestamp to that timestamp. Or I would say I want to split the Did I say split the audio? I want to, no, so, okay, my first example is that I want to split the VOD, I want to split the video and take out just like this one chunk of video. Um, and the other thing that I could ask it to do is actually split the video and the audio and just give me the audio track itself or just the video track so I can like use it for various purposes. But yeah, all of this stuff, I would be asking Gemini how to do this, and then Gemini would give me like a small code snippet or an invocation kind of thing, like calling ffmpeg and then passing so and so flags, and then your input goes here, the output goes there, and all of that, and then I just copy paste that and get my output. So anyways, a lot of times I'm going to be using some sort of automated system to accomplish this. So I might as well just use the Python library for it. I believe there's both Python and Rust. I also believe there's multiple libraries for this. Hold on. Python, ffmpeg. Okay, Python bindings for FFmpeg with complex filtering support. I don't know what filtering means in this case. I'm going to have to look into the exact meaning for that. But let me look at this. Okay, so this library has not been updated in the past 4 years. That's not necessarily a bad thing though, because it could just be very feature complete and it doesn't need, because like FFmpeg is a very mature tool. It's been around for years, if not more than a decade, and it's a very mature tool. So it's very much possible that this entire library is just very feature complete. What it was supposed to do, it's able to do that, and that's it. It doesn't need to do anything more. It doesn't need anything more. It could also be it could also just not be being maintained anymore. That's a possibility as well, but they haven't mentioned anything about that here. It's also not archived, so let me check the issues section. There's an issue from last month. There's an issue from a couple of days ago. Please update the syntax on README. Okay. Support my support multiple identical inputs. Okay. Zoom pan filter issue. No, you know what? Okay, let's think about this for a second, right? I have access to the CLI. If I have access to the CLI, I do not need a wrapper around it. I can access the CLI directly from what do you call it? Directly from Python. I can access that specific CLI directly from Python using something like subcommand or subprocess. I think it's called subprocess. I can access it directly using something like subprocess, or there's process.run or something like that. They have like a library that lets you launch another application as like a child process, but it's like a separate process. It's not blocking your current thread anyhow. Um, yeah, I could just do that whenever it's required. I could do that. That's going to be a bit more error prone, but it's only going to be more error prone if I'm doing a lot more dynamic stuff. If I make sure that the syntax that's being used is correct, and flags and stuff are being passed in properly, their inputs are being passed in properly, if I make sure of all of that, I think we should be good. I think we should be perfectly fine. We can test it out actually. Yeah, yeah. We can test it out. But here's the thing, right? Um, so I'm pretty sure this thing is being used until today. Nobody has mentioned that this thing is broken, right? This no nobody has oh, hold on. I should probably open it here. Give me a second. I might as well just show it to you guys here instead of looking at it elsewhere. Okay, what's it called? FFmpeg. Oh, I'm gonna have to mention the person's name as well. Oh, I can just search. Give me a second here. Uh, okay. Oh, there it is. FFmpeg Python. And there it is. Okay, there's another one here called Python PyAV. We'll take a look at this as well. And this has been updated recently. So we're gonna take a look at both of these. There's another one called Python FFmpeg, which I don't know if it's its own thing or if it's like a fork. Yeah, I'm not sure. Anyways, I'm gonna switch now so I can show you guys. Okay, wait, did it switch? Yeah, it switched. So this is FFmpeg Python, and this is what I was talking about. Like I'm not seeing many updates here, which again, okay. So I focus on the updates first, right? Just to see if the thing is being actively maintained. But that's like active maintenance isn't always necessary. It depends on the situation. It depends on the kind of repo it is. Is it a tool? Is it something built for like one specific purpose and it's able to accomplish that? Is it a library of some sort? Is it something that needs to be continuously evolving, something that needs to have features constantly added to it? Or if it's something that, it's supposed to accomplish a fixed set of features, and once you have accomplished that, that's just it. You don't need to change things a whole lot anymore, right? Is I don't know what the case is over here, so I can't really say that, oh, it cannot be used. Um, that being said, this is also a thing. Pythonic bindings for FFmpeg libraries. And this is actively being developed. Now, what are the features here? PyAV is a Pythonic binding for the FFmpeg libraries. We aim to provide all the power and control of the underlying library, but manage the gritty details as much as possible. PyAV is for direct and precise access to your media via containers, streams, packets, codecs, and frames. It exposes a few transformations of that data and helps you get your data to and from other packages, example, NumPy and Pillow. This power does come with some responsibility, as working with media is horrendously complicated and PyAV can't abstract can't abstract it away or make all the best decisions for you. Okay, that's fair. If the FFmpeg command does the job without you bending over backwards, PyAV is likely going to be more of a hindrance than a help. That's okay. Okay. I guess that's something to take into account, that what I'm trying to do, which in this case is nothing complex at all. Like, at all. Literally, the only thing that I'm using FFmpeg for, or what I plan to use FFmpeg for in this case, that's a mouthful to say each time. FFmpeg. FFmpeg. Let me just call it FPEG. Um, FF. MPEG. FempEG. FPEG. dude. Okay, let's just um FF. Let's just say FF. So um where where was I? Literally, the only thing I'm going to be using FFmpeg for is for splitting. Actually, two things, not one thing, two things. Literally, the only two things that I'm going to be using FFmpeg for is one for slicing videos, so cutting out small chunks. So out of a 2 hour video, maybe I might only want to get 1 minute of it from X timestamp to Y timestamp. Like that's going to be the slicing that I'm trying to do. So one thing I'm trying to use FFmpeg for is slicing, and the other thing I'm trying to use it for is splitting the audio and the video. So if I'm able to accomplish both of these things using just bare bones CLI, and passing all of the relevant data into like subprocess.run or popen.run or whatever I'm supposed to use there, if I'm able to accomplish all this with just bare bones CLI, then I don't think I need to do any of this. Um, it also mentions, yeah, but where you can't work without it, P PyAV is a critical tool. Okay, so they have binary wheels for it. Okay, cool, 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 great, awesome. Read the docs. Let's see if what is okay, whatever. Let's open this up. Oh, is there dark mode here? Okay, it's fine. Right. So and so, so and so, so and so. We are done reading all that. Great. Awesome. All right. So they have format, device, codec, filter, scale, sample, and a few more utilities. Basic demo. What is this doing? Container. Okay. Enumerate. Frame.to image. Save so and so. So I'm guessing this is splitting up a video um, into multiple images. All right. Okay, our goal is to provide all the features that make sense for the contexts that PyAV would be used in. If there's something missing, please reach out on GitHub and so and so, so and so. I'm wondering if there's a situation, or there might be a situation later on, where I find out that I'm trying to do something incredibly simple, but I'm not able to do it with PyAV because they didn't implement the feature because it's really simple to do. Yeah, I'm wondering if like I might run into that kind of a situation later on. Let's see if there's like more examples here. Basic demo, overview, cookbook, audio basics, recording the screen, recording a face cam. Okay, saving keyframes, remuxing, parsing, threading. Okay, let's take a look at the basics. If you just want to look at keyframes, you can use so-and-so, okay. Remuxing is copying audio and video data from one container to another without transcoding. By doing so, the data does not suffer any generational loss and is the full quality that it was in the source container. I keep seeing this term container. I'm going to need to do some research on FFmpeg and the various concepts surrounding it before I do anything with, or maybe I could try just using the FFmpeg CLI Like just a little bit. Actually, no, no. We can do it in this way. So the output here is supposed to be this file. Make an output stream using the input as a template. This copies the stream setup from one to another. Okay. All right. Okay, parsing. Sometimes we have a raw stream of data and we need to split it into packets before working with it. We can use so and so. All right. Threading. By default, the codec context will decode with slice threading. This allows multiple threads to cooperate and decode any given frame. This is faster than no threading, but not as fast as we can go. You know what? That's fine. This is not enabled by default. Well, okay. What's not enabled here is yeah, this kind of threading, frame threading or auto threading. That's what they're talking about. Not enabled by default because it does change the API a bit. You will get a much larger delay between the starting between starting the decode of a packet and getting its results. Take a look at the output. You know what? We can look into better threading later on because in this case, I don't need more speed. I just need the functionality. Then there's recording the screen. This is written for Mac OS. Other platforms will need a different file and format pair. That's interesting. I didn't know you could record the entire screen using FFmpeg. Okay, recording a face cam. If you can record a face cam, you can probably also display. Right. Okay. So at some point later, if I ever wanted to write an application that an application for the webcam, I could probably use some version of words, some version of FFmpeg. Give me a second. All right. Okay. Wait. Hold on, dude. We were supposed to be discussing. I just realized this. We were supposed to be discussing like this, all of this. Well, I mean, okay, we've done like we've done a fair bit of the research here. Um, oh, sorry, zoned out. Okay, so yeah, in terms of streaming, actually three things that I need to focus on, but there are more two things. So like, um, first I need to focus on rebuilding my VTuber application using Rust and Nano. That's gonna, introduce me to Nano and make me more comfortable with working not only in Rust but also, you know, working in a framework like Nano to build various like graphical application things. There are a bunch of like different tools that I wanted to set up for the stream, and I was planning on aiming for Nano specifically. Um, there are a bunch of like ESP32 projects that I would like to also look into. Dude, you know what I had in mind? There was this project idea. I don't know if I mentioned this before. You know what? I could look this up real quick. I'm just gonna open up a Gemini conversation. Um, Also, another interesting project that I might look into at some point later on is a DNS sinkhole, but using ESP32. So one of my family members mentioned a Pi-hole to me. Pi-hole is basically a DNS sinkhole, which you would be running on Raspberry Pi, I'm assuming, because it's called Pi-hole. I don't know if it was built for any other platforms, any other like architectures or whatever. But yeah, there's a thing for Raspberry Pi, and that got me wondering that hey, the actions that this Pi-hole software is going to be performing, are they that complex that they cannot be performed by a microcontroller? Um, and it turns out, no, they're not that complex that they can't be performed by a microcontroller. It's just that you would be working on a much smaller scale compared to a Raspberry Pi, because a Raspberry Pi has GBs of memory and a stronger processor. I don't know stronger by how much, but it is significantly stronger. I believe it's also a 64-bit system. It's not a 32-bit system. Let me just look that up. I don't want to give wrong information. ESP32 is definitely 32-bit. Okay. Is Raspberry Pi 32-bit? Okay, somebody's asking here. Okay, is Raspberry Pi 64-bit? Let me just look that up. The new Raspberry Pi models, Pi 34502W, have 64-bit processors and support for 64-bit operating systems, while the older models, Pi 120, are 32-bit only. But the official Raspberry Pi OS offers both 32-bit for all models and 64-bit for newer model options, with 64-bit generally recommended. Okay. All right. So Raspberry Pi is 64-bit, and ESP32 is 32-bit. I forgot why I was talking about like the bit size, the like bit depth. Anyways, you would be um, doing things on a much smaller scale compared to like on an ESP32, you'd be doing things on a much smaller scale compared to something like the Raspberry Pi, right? Because on a Raspberry Pi, you have GBs of memory. On an ESP32, you have like KBs and maybe MBs of memory. Maybe MBs. Mostly it's KBs of memory. Then on a Raspberry Pi, you have a more powerful processor than an ESP32, and there's a couple of other things here and there as well, but mainly um, it's the what do you call it? Mainly it's the processor and the memory that make this massive difference. Where was I going with it? Yeah. So you would be doing things on a much smaller scale. However, this shouldn't be a problem for you if you're dealing with a small network, at least according to Gemini. I'm gonna have to test this out, but apparently it shouldn't be a problem for you, um, as long as you're dealing with a small network of just like a couple of devices, and if you take the right steps to minimize latency and lag and stuff like that, and minimize unnecessary calculations or unnecessary instructions and stuff taking place, you can actually pull this off. And if I'm able to pull this off, this would actually be a significantly cheaper um, sync hole, DNS sync, DNS sync hole, DNS hole, DNS sync hole. I think, yeah, um, yeah, DNS sync hole. That's what it's called. Where was I? Where was I going with this? So okay, yeah, that's another project that I want to do. But I was gonna. Oh yeah, wait. I just remembered. I just remembered what I was gonna ask Gemini. Hey, so I'm looking to buy one of those um, mic modules that can be connected, controlled by an ESP32. I'm going to be doing ESP32 coding in Rust, just mentioning that if that makes a difference. What I'm wondering is if I do a significant amount of DSP on the ESP32 itself, actually significant amount of DSP, either on the ESP32 itself, let me put that in brackets, either on the ESP32 itself or by sending the raw bytes to a computer and doing DSP uh, on there instead, would I be able to get decent mic audio quality for something like recording a video or streaming. Actually, I'm not planning on using it for streaming, but like just in case, or streaming or something. Because I'm very curious about this because these modules are incredibly cheap, and that's one of the reasons why I'm buying it, right? But the cheapness comes with, ironically, a price. I'm wondering if I'm going to be paying a price in audio quality. Like, is it just going to be picking up a shitload of noise? Am I going to have to implement my own sort of stuff in order to prevent various types of noise? The first thing I'm going to have to do is put one of those like pop filters onto it to kind of prevent, uh, different types of extra stuff like the pops from the p's and uh, the hissing sound from the s's and various other like maybe wind blowing something or whatever, just to prevent all that from being picked up. I would have to employ certain techniques. Where was I going with this? I forgot where I was going with this. Okay. uh You absolutely can get decent audio, but there's a clear distinction between IoT voice assistant quality and content creator quality. Since you are using Rust, you are in a great position for performance, but you'll need to be strategic about where the heavy lifting happens. Here's a breakdown of how to. You know what? I'm wondering if I could introduce an extra ESP32 into the mix, just to act as a DSP or as a DSP processor. Yeah, I wonder if I could do something like that. Imagine this, right? Imagine I am able to set up a parallel connection. I need to look this up. Hold on. Uh, wait. Don't do that. Don't do that. That's the wrong keyboard shortcut. Okay. Uh, what was I? What was I? Okay. I do ESP32 projects using Rust. I've heard of serial communication, both sync and async. but these forms use a smaller number of wires. What I'm wondering is, what if I didn't have a shortage of um, pins to send data out of? What are my options then? Because this is what I'm wondering, right? What if we are able to do like a parallel communication kind of thing? Because serial communication is generally, the idea is to use the least amount of pins possible, and that is why they have to employ all of these very clever techniques. They have to set up these protocols where they are able to do communication with 2 pins or 3 pins, and establish a proper like communication channel using only those small amount of pins. And in this way they're able to then control multiple such modules using this same protocol, but like, different groups of pins. In my case, what if I have multiple ESP32s? I actually do have multiple ESP32s. What if I have multiple ESP32s and there's multiple like pins on them that are just free, and I'm able to set up parallel communication instead of serial communication? Because I remember when I was initially learning about, communication in general, when it takes place between these microcontrollers, or between these devices and stuff, it was mentioned as, two forms of. Actually, I can show it here. Hold on, I can show it right here. This one says serial. I think it does also mention parallel, but yeah, okay. While this is loading up, I'm gonna read out the. Oh, let's get out of. Oh, the images are shown here, right? So it mentions here. Yeah, okay. Let's go from the starting. Embedded electronics is all about interlinking circuits, processors, or other ICs to create a symbiotic system. I'm not sure what that means. In order for those individual circuits to swap their. Yeah, okay. Sorry, I was just looking at something. In order for those individual circuits to swap their information, they must share a common communication protocol. Hundreds of communication protocols have been defined to achieve this data exchange, and in general, each can be separated into one of two categories: parallel or serial. Okay, parallel versus serial. Parallel interfaces transfer multiple bits at the same time. They usually require buses of data transmitting across 8, 16, or more wires. Data is transferred in huge crashing waves of ones and zeros. Okay, this is an 8-bit data bus controlled by a clock, transmitting a byte every clock every clock pulse. 9 wires are used. Yeah, so 8 for each of the bits, and then one for the clock. Then serial interfaces stream their data one single bit at a time. These interfaces can operate on as little as 1 wire, usually never more than 4. So this is what I was talking about with, serial communication. They use the least amount of pins possible. Right. Parallel communication certainly has its benefits. It's fast, straightforward, and relatively easy to implement, but it requires more. It requires many more input slash output lines. If you've ever had more, wait, if you've ever had to move a project from a basic Arduino Uno to a Mega, you know that the I/O lines on a microprocessor can be precious and few. So we often opt for serial communication, sacrificing potential speed for pin real estate. Okay, asynchronous serial, suggested reading. Okay, this doesn't go into parallel. Hexadecimal rules of serial. Oh, okay, okay. There's still more. Serial, serial. This is serial. This is serial. Serial. Oh, we are looking at serial. We are looking at serial communication. Is parallel mentioned anywhere here? You know what? No. Okay, while that's loading up, I can wait. Um, I'm wondering if like parallel is even mentioned in like suggested reading or something. Okay. No, it's not. All right. Just a second. Right. So, yeah, let's keep going. Let's keep going down. See if there is anything relating to parallel. Wait, is UART? No, that's still serial. Okay. That is still serial. Okay. Okay. There's like parallel is just straight up not mentioned here. Okay, fine. Let me try and get my information from Gemini. Okay. Right. Since you have more pins to spare, you're moving from the world of serial, sending one bit at a time, to the world of parallel communication. In parallel, you can send multiple bits using an entire byte simultaneously over multiple wires. On an ESP32 using Rust, this approach can significantly increase throughput, though it introduces some complexities regarding timing and skew. Parallel bus GPIO port wiring. The most direct way to use the extra pins to use extra pins in a parallel bus. No, hold on, what? The most direct way to use extra pins is a parallel bus. Instead of toggling one pin, you toggle a group of 8, 16, or 32 pins at the exact same time. How it works, you map a value like so and so to 8 different GPIO pins. Rust implementation in the ESP HAL, you can use atomic GPIO operations or write directly to the GPIO out register to set multiple pins in a single clock cycle. Pros, extremely fast, no serialization overhead. Cons, high pin cost, requires careful synchronization so the receiver knows when the data is stable. Then we have I2S, inter IC sound in parallel mode. While I2S is typically used for audio, the ESP32's I2S peripheral has a parallel mode, often used for driving camera sensors or LCDs. How it works, it uses the internal direct memory access controller to pump data from RAM to a set of GPIO pins without using the CPU. Why use it? It's much more efficient than manually toggling GPIOs in a loop. True, true. It handles it handles the clocking and timing for you. It handles the clocking and timing for you. This is important. Okay, it's handling the timing. Rust support. The ESP-HAL crate provides drivers for I2S. You can configure it to output 8-bit or 16-bit wide data. I feel like that would significantly simplify things for me because I'm not going to be stuck implementing the actual communication protocol, and I can focus on actually just, sending the data over. Now here's why I'm mentioning this, right? Being able to send more data over at once is going to significantly reduce the lag or the latency in this case. And so, if, for example, I wanted to do let's say, for example, I wanted to do three, I don't know, uh, two or three separate ESP32s. One one is responsible for the initial signal, getting the initial signal from like the mic module, and then doing a tiny bit of processing, whatever processing needs to be done. At the very least, converting that data into digital data that can be, you know, consumed by some sort of algorithm or something. Once we have that raw data, then I can send that data over a parallel bus to another ESP32, where more more heavyweight DSP can take place, more heavyweight processing can take place, and just like this, I can, if need be, I can introduce another ESP32, which where even more processing will take place. This would like it would depend on what processing I'm doing exactly. I'm gonna have to like study a little bit about DSP before I set something like this up. But I'm pretty sure I can accomplish it in what do you call it? I'm pretty sure I can accomplish it in Rust, and I'm also sure that there's probably going to be some crate that has no STD support for DSP, meaning I'm going to be able to run DSP operations on a microcontroller. Let me just look that up real quick. Rust, DSP, no STD. I wrote DRP. Okay, great. DSP, no STD. Several excellent no STD compatible crates for DSP are available, suitable for embedded systems and bare metal environments. These libraries often require the alloc crate for dynamic memory allocation, which can be provided in stable Rust. So we have DASP. I haven't looked into that for a while. Digital audio signal processing. This is aimed specifically at audio. I sorry. I should look into this. Yeah. Then there's okay, FunDSP has it as well. A functional composable audio processing and synthesis library. I was planning on looking further into FunDSP. I haven't, okay, there's another one called MicroDSP, which is a collection of DSP algorithms optimized for embedded systems. I haven't looked into that, but it seems worth looking into specifically because it's optimized for embedded systems. But that being said, maybe the Rust compiler might apply its own optimizations. I don't know. I can look into that later. Then there's one called NDSP, then there's something called libpower as well. So right now I'm looking at DASP and FunDSP, but more specifically FunDSP because I was planning on using FunDSP previously for other stuff. Uh, but I'm wondering if DASP is able to do a lot more stuff. Though I guess it would depend on what I'm trying to do exactly, right? I'm gonna need to do research on doing DSP on audio and learn exactly what kind of DSP I'm supposed to be doing. Right. Okay. So that solves it. So we can look at. Okay. Wait. Actually, that doesn't solve it. Wait. ESP32 I2S. Inter-IC sound is a synchronous serial communication protocol used for transmitting audio data between two digital audio devices. Okay. ESP32 contains two I2S peripherals. Okay, this is talking about serial, specifically serial. This is not talking about parallel. Is the word parallel even mentioned anywhere here? Okay, LCD/camera mode is only supported on I2S0 over a parallel bus. Okay, this is what it is. Okay, all right. Okay. So and so should transfer at master TX mode. For camera mode, I2S0 should work at slave RX mode. These two modes are not implemented by the I2S driver. Okay, this is like LCD and camera mode, right? I need to look into is that the only thing that says parallel? Yeah, that's literally the only thing that says parallel. Okay, I'm gonna have to look into this, but I'm sure there might be ways to go about setting this up. Then they have SPI with multiple lines. If you like the reliability of SPI but want more speed, you can use multi-IO SPI instead. No, you can use multi-IO SPI instead of using Mozzie. Instead of using one Mozzie wire, you use four or eight. Standard SPI is one wire for data, and quad SPI is four wires for data. Octal SPI is eight wires for data. In Rust, you would configure the SPI peripheral in your peripheral access crate or HAL to use the extra pins. This is common when interfacing with high-speed flash memory or PSRAM. I didn't know that was an option. Wait, that's crazy, dude. I didn't know that's an option. Then there's a remote control peripheral. I remember this. I thought this was something to do with like infrared. The ESP32 has a unique peripheral called RMT. While usually for infrared remotes, that's probably why I remember infrared, it's essentially a high precision pulse generator, the pin rich strategy. You can use multiple RMT channels in parallel to drive different data streams within nanosecond precision. This is how high density LED strips are often controlled when you have when you have many parallel strips. A note on skew. When you use many wires, you encounter signal skew because wires have slightly different lengths or electrical properties. One bit might arrive at the receiver a few picoseconds before the others. At very high speeds, this causes data corruption. This is why high speed parallel communication usually requires a clock or strobe wire to tell the receiver exactly when to latch the data. Okay, so I guess that's where we require a clock. Okay, cool. Right. Okay. So yeah, yeah. I'm gonna look into this. This is definitely one of the projects that I wanna set up. I wanna see how far I can get in terms of creating, you know, a microphone, a usable microphone that I can then connect to maybe my computer or to my phone or whatever. Shit, maybe even connect it over Wi-Fi. I don't know if the Wi-Fi connection happens to be fast enough and I'm able to, get the get the audio in with the least amount of delay. Um, then like I mean the experiment is successful, right? I might actually make this a thing then, if the thing is successful. For now, I'm gonna have to look into the various um, communication modes that I have to set up. I also have to order the hardware, but now this is making me a little more excited for ordering this hardware. Um, I'm excited for this. I wanna test this out. But yeah, dude. Okay, so I think that's gonna be it for today's stream. I was debating whether I want to raid anyone or not. Um, Hold on just a second. Hey, you know what? We're gonna go to this person. If they are not okay, never mind. They are follower only. Okay, okay. Let's go to someone else. Okay, I don't know what this person is doing. We're gonna go. We're gonna go check this person out. Okay, their name is Adi Dwivedi, and they are working on. They're doing a study stream. So we're gonna go check them out. Okay. Let me type in the raid command. Okay, so that's gonna be it for today's stream. I'm looking forward to this year, dude. I'm excited. I'm excited. I want to get into all of these projects that I have planned. I think I really want to focus on the auto clipper a lot more because I need to set this thing up to get my content out there quickly. Um, so I'm gonna need to start doing research on. I mean, most of the time, I believe I'm just gonna be using the Transformers library to load whatever the models are. But yeah, I need to set up the entire like workflow and stuff. There's also like the software architecture that I have to look into, like, or rather the well, yeah, basically the program workflow, how things are gonna go from from the beginning to the end, how the data is gonna flow, because there are certain situations where I might need to pass data into the LLM multiple times. So like, should I pass one big batch and get, all the answers at once, or should I do multiple invocations? I need to see how to go about doing that. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.